Alright, so we're going to take a look at another replacement rule from SD+. This one is called exportation. I'm not exactly sure where that name comes from, but in SD+, whenever you have if P, then if Q, then R, you could rewrite that as P and Q, if P and Q, then R, or vice versa. So we're going to go ahead and we're going to establish that equivalency in our system SD. So again, anything you can do in SD+, you can do in SD. It just might take you many more steps. So let's start with the left to right direction. Okay, so we're going to prove this, and then of course we have to get the other direction. So starting up here, now what we're trying to prove is a conditional. So we should start this the same way, the same thing that we have been doing. We're going to assume the antecedent of the conditional. So we assume the antecedent for purposes of conditional introduction, and we're going to try to show that the consequent follows. So how can we do that? Well, let's start by just taking this conjunction apart. So we get P and Q on separate lines where we can work with them. So both lines 3 and 4 from line 2 by conjunction elimination. Okay, now from line 3 and line 1, we can get if Q then R. By conditional elimination. And now we're done. We can get R by conditional elimination for lines 4 and 5. Okay, and now because we have R here, we assume P and Q, and we got R. We can go ahead and close this subderivation off. And we have this conditional by lines 2 through 6, conditional introduction. Alright, so now we're done with this direction. We can start a new subderivation, and we'll try to derive this from this. So again, what we're trying to get here is a conditional, so we should assume the antecedent and try to show that the consequent follows. Okay, so it looks like we're trying to prove another conditional here, so we should do the same thing. We should start another subderivation, assume the antecedent, and try to show that the consequent follows. So how can we get R here? Well, what if we put P and Q together? Then we have the antecedent of this conditional here on line 8. So it's supposed to be an ampersand. We have our line 9. We have our line 9 here. So okay, sorry, this is getting really bad. We have our line 11 here by conditional introduction on lines 9 and 10. Okay, so now on line, this is why you should always do these in pencil. You should never use a pen to do derivations. So on line 12, now we have R by conditional elimination, lines 8 and 11. And we're able to close this little subderivation off, and we can conclude if Q then R by lines 8 through 12, conditional introduction. So finally on line 14 now, we can close this out, and we've shown that if P, then if Q, then R by conditional introduction, lines 9 through 13. So finally we've established this biconditional here, 1 through 7, and 8 through 14, biconditional introduction.